Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. My name is Uzair and I'm going to teach you physics class 8th. In our previous lecture, which I delivered last week, we talked about physics, that is the study of physical universe in general, and matter and energy and the laws and rules which govern their interrelationship in particular, and branches of physics, and especially mechanics and then its branches. Then we moved on to dynamics, its branches. Then we talked about rest and motion. Now let us recall what is rest and what is motion. If a body does not change or is not changing its position with respect to its surroundings, it is said to be at rest. And what is motion? If a body is changing or changes its position with respect to its surroundings, it is said to be in motion. Having said this, we moved on to the next topic, absolute versus relative. Now, what is meant by absolute and what is meant by relative? Previously, it was thought that the world or the physical universe is an absolute entity, but Einstein proposed and it was proved that everything in this universe is relative. Our rest and motion are notions that are relative to our surroundings. Nothing in this universe is absolute. Then we moved on to the types of motion, and we first discussed translatory motion and its subcategories like linear, circular, and random motion. All these types are subcategories of translatory motion. Now, what is translatory motion? The motion of an object around a line or along a line is called translatory motion. If the line is straight and the body moves from one point to other point, it is said to be linear motion. But if the starting point coincides with the final point, the path is circular, and we say that this motion is circular motion. And if there is no regularity in the path, rather it's a disorganized, haphazard, zigzag type of motion, we call it random motion. Linear motion, circular motion, and random motion are subtypes of translatory motion. And again I repeat, what is translatory motion? Motion of an object or a body along a line is studied under translatory motion. Then we talked about rotatory motion, the motion of an object or body around its axis. Then we talked about vibratory motion, to and fro, back and forth motion of a body about its mean position is called vibratory motion. Our today's lecture is about rotatory motion and vibratory motion. What is rotatory motion? Motion of an object or a body around its axis. We must first define what is an axis. An axis is a line, an imaginary line sometimes, that passes through the body, around which the body rotates. It means that the object will stay at a single position and will be rotating around that axis. That axis may pass along the y-axis, it may pass along the z-axis, it may pass along the x-axis. Its orientation doesn't matter, but the rotation of the body around its axis is important, and that is something we study in rotatory motion. Motion of an object or a body around its axis. What is vibratory motion? Motion of an object about its mean position. We use the terms to and fro, back and forth. For example, people who have got pendulum in their houses, in their homes, they know that the bob of the pendulum vibrates along its mean position. Similarly, the motion of a swing is an example of vibratory motion. Having said this thing, let us read the textbook and see what it explains about rotatory motion and vibratory motion. First of all, we are going to study rotatory motion. Study the motion of a top as this example is showing you. It is spinning about an axis. Particles of the spinning top moves in circles, and thus individual particles possess circular motion. Does the top possess circular motion? The top shown in figure 2.9 spins about its axis passing through it, and thus it possesses rotatory motion. An axis is a line around which a body rotates. In circular motion, the point about which a body goes around is outside the body. In rotatory motion, the line around which a body moves about is passing through the body itself. Can you spin a ball at the tip of your finger? The spinning motion of a body about its axis is called rotatory motion. Now, this is the definition according to your book. Can you point out some more examples, more differences in circular and rotatory motion? The motion of a wheel about its axis and that of a steering wheel are examples of rotatory motion. The motion of Earth around the Sun is circular motion and not the spinning motion. However, the motion of Earth about its geographic axis that causes day and night is rotatory motion. As you can see, this example, the top, the ball at the tip of a finger, the wheel of a bicycle, and the steering wheel of a car, they all possess rotatory motion. Now let us move to the next topic, vibratory motion. Consider baby in the swing as shown in figure 2.10. As it is pushed, the swing moves back and forth about its mean position. The motion of the baby repeats from one extreme to the other extreme with the swing. To and fro motion of a body about its mean position is known as vibratory motion. Figure 2.10 shows the vibratory motion of a child and a swing. Figure 2.11 shows vibratory motion of the pendulum of a clock. Figure 2.11 shows to and from motion of the pendulum of a clock and about its mean position. It is called vibratory motion. We can find many examples of vibratory motion around us. Look at the children in a seesaw as shown in figure 2.12. Figure 2.12, a baby in a cradle. Figure 2.12 shows vibratory motion of children in seesaw. A baby in a cradle moving to and from motion of the hammer of a ringing electric bell. and the motion of the string of a sitar are some examples of vibratory motion. Dear students, I hope that you have got a clear idea of what is meant by rotatory motion and what is meant by vibratory motion. I hope to see you soon with my next lecture next week. But before I say goodbye to you, I must tell you that next week you are going to submit your project, that is vector voyage, and you can search on the internet and you can have basic information about vector voyage from the internet. Especially on YouTube there is a channel, Teach Engineering. There will be a video that will show you what is meant by vector voyage. You must prepare yourself for the next week project, and the week next to the fourth coming Wednesday, I will be asking you to submit your projects, and that is you must mention your names, class, sections, and your topic, that is vector voyage, and how did you accomplish your project.